everyone. Thanks so much for coming to this talk. So my name is Bonnie. Thanks so much, Will, for the intro here. And today I'll be talking to you all about how OpenAI deployed an internal AI data agent to help our teams answer questions about their data. So let me first kind of start with the problem. Let me paint you a picture. So your business lead comes to you and asks the question, how many ChatGPT Pro users do we have in Italy? You consult a data scientist, but they're like, oh, this is kind of hard. Let me get back to you. They don't know which table to use, and then they end up consulting another engineer, but they don't know. And you go back and forth, and there's like 3 quick meetings and 5 Slack threads, and finally you have an answer. But it really shouldn't take this long. Simple questions like these should be simple and not this time-consuming. And the reason why it's so hard today in practice is because usually there's just so much data to sift through. So I'm Bonnie, and I'm on the data productivity team here at OpenAI, and I'm here today to talk to you about how we solve this problem. So here are some key takeaways that I hope you all will get from my talk. Firstly, the importance of the right data context. And then I'll be talking about how memory was really useful in our case for the agent's self-learning, and also how important evals are for us to make sure that the agent doesn't regress. OK, let me start off with an overview of the scale of our data platform to, again, provide more context and the problem. And then I'll go into implementation specifics of the agent, the learnings we had, and then finally how you can actually maybe implement this if you're looking to do something similar at your company. Great. So at OpenAI, 80% of the company directly uses our data platform. That's 80% of the company using our team's 15 tools to answer questions over 600 petabytes of data. The data is growing rapidly, and there's 70K data sets. This means we have many more questions to answer. But there's so much more data to sift through to get the right result. For example, when ChatGPT launched in 2022, we were asking ourselves, how many daily active users are there? But now the question is more like, oh, in this region, for this particular feature, what is the daily usage? And that's a kind of a similar question, but as you can see, that's like a much, you have to delve through a lot more to get that answer. One of the reasons why this is hard is because table discovery becomes a lot harder at scale. A common problem is difficulty in finding the right table because maybe it's similarly sounding, there's different nuances. And really, it's unclear just from the naming or even from the schema sometimes what data is actually in them. Or maybe like this table was meant for this purpose, and then due to a launch, it was repurposed and now actually contains more data than how it was originally described. And here's another problem, and this is one thing that actually came up from one of our data scientists. Each table data is actually really hard to understand as well. Some tables have encrypted IDs, some tables have unencrypted IDs, depending on whether you're reviewing them in the raw scrubs form, but maybe you want to join them, right, to find some information. Some tables have columns that include, adjustments for fraud rates, some tables do not. And so all these little nuances actually do meaningfully impact the final answer. And missing one of these little nuances could actually lead to an answer that is wrong by an order of magnitude. And so this is just so important to get right. And here's another problem, writing SQL manually. The SQL statement is about 160 lines of code, but I have no idea whether it's right or not. Because who can remember all the aggravating ways we date format or write for format queries or Trino arrays or one index? Who has time to remember all this? So how can we do better? So at OpenAI, we built our internal agent to basically take the full context of our data platform and answer these questions for you. So it has all these bits to solve the problems that I just outlined. So kind of at its core, this is what it looks like. On the left, you see that, OK, we have a UI that you can interact with the agent. We have you can set up a local or remote MCP server. So if you're using Codex, you can hook that up, or maybe Cursor. And then we also have a Slack agent that you can talk to our internal data agent with. But really, at its core, we have our backend service, and then it talks to our model. So let's go through some examples to kind of illustrate what it actually looks like. So here's my question to the agent. I'm looking at New York taxi trips, and I want to know which pickup drop-off pairs are the most unreliable. And so by unreliable, I'm defining it as the biggest spread between typical and worst-case durations. And so let's start playing this video. Here we go. So this is just kind of a live video. So as you see here, it first does kind of a tool call search of all the data it has access to. And if you guys can all see that top part, it was able to find the toy data set, which we're using for this question, which is our New York taxi sample data set in our data catalog. And so now that it's gotten the right context, okay, it's found a reasonable table, it's actually starting to craft a SQL query. And it's able to figure out even how to write these queries because it got schema informations. And now it's kind of iterating on the SQL to answer the questions. So it goes through a bunch of steps here, but kind of much like a human would. You first run some queries, get some sense of the data, then you actually write the right queries. Like for this case, you have to do some percentiles maybe, right? If you look, there's some sorting things with the data as well. So basically all the manual steps of figure out what's kind of in here, figure out how to parse it, figure out actually what SQL to represent the meaning. This is all handled by the agent, just writing these statements and analyzing the data and going back and forth. So here it's still running the query, and I feel like maybe you might think oh, this is actually kind of long in this video, but it would take a lot longer if you were to do this by yourself. But maybe let's skip ahead here. Okay, it's doing some ratio things, running again, and towards the end, it does some analysis just to format things. So here, okay, we have figuring out the timestamps, organizing the final message to be structured. And here we go. We have a final answer. So the first part is the assumptions that the agent took to get this information, just in case maybe got something wrong. And then the second part down below, which I will scroll to in just a second, is, okay, there we go, actually the results. Okay, so it's those zip pairs, and these are times along with that. This is the reproducible SQL if you want to see actually how it got there. And okay, that was the answer. Weekdays, so basically morning rushes and the evening rushes, and then late night for availability. This makes sense. So this is kind of an example of how I was able to get to the answer. And so another thing that is pretty common that we see a lot of data analysts do is plotting graphs. So here we can ask the agent directly, okay, let's say we have an answer, how do we get a nice visualization? Maybe we're adding it to a report. Maybe it's just easier to see the data visually because it's a big table or something, right? So the agent actually uses the context in the original thread, and it's able to show the query, okay, used for plotting and generate a nice graph. And so we find this is really useful just for just deep diving into analysis, but also when folks want to move everything they did to a different form, like, okay, you're crafting a weekly update, you're giving an exec status report. This has been really helpful for them. So now we have a rough idea of how the agent is powered. Let's go through a concrete example so you can see more how it actually might work in production. So suppose I'm a data scientist, and I'm investigating a huge upward spike in ChatGPT late March 2025. Okay, the first step in reasoning is checking whether the spike is real and as I described. So these are actually screenshots from the chain of thought. As you can so from before, this is the same thing for this question. And as you can see in this chain of thought in particular, it's kind of validating that the spike is real. It's looking at the numbers pre and post spike. Did I hallucinate? Am I just making stuff up? So here is what it basically does. It just sets the scene. The agent just basically goes, okay, let's actually figure out what the data is for this. Okay, the second part is kind of now the outside context beyond just the data. So this is looking at our internal knowledge. So here it's finding extra. We picked a table. It's finding extra context in the table from a dashboard. It also looks at a Notion doc to make sure what it's kind of once it's found some initial leads. Table leads here, it makes sense for the question. And then we see a similar part, similar to the New York taxis example earlier in that toy data set. The agent's kind of slicing and dicing the data, running SQL queries, just to make sure that, OK, let's kind of look into the actual data to find any insights. So here you can see it's kind of slicing by plan and region. For example, this is what you might do if you're actually approaching this, right? Maybe if the spike is specific to a particular cohort of users, that will show up if you group by a certain way, right? And so that's effectively what the agent is doing over here. So this is just really useful. So instead of you doing this, aggregation analysis, all of that, the agent's just doing it for you here. And then the next part, after it has done a bunch of these queries, it's gotten these data insights, it's now kind of exploring different hypotheses. So based on this data, it's making judgment calls. Why is this happening? And in this case, one hypothesis here that it's exploring is a logging bug. Maybe our users spiked because we double logged. Stuff happens in production. And so here's one exploration of this. And then as it goes through, I think this agent basically picked image gen as as one plausible hypothesis, and now it's validating itself. So here it actually uses web search to validate that this was correct. Because if it is a release, then we have release notes, for example, that this even happened. And so here we see that, OK, it looks at these, it finds this in the release notes. It also finds a TechCrunch article in the release notes. So effectively, it's basically just looking at, OK, this is, so from the data, I think this is an image gen launch. I see image gen launch then. But if image gen launch, there should be some press about it. Let's make sure that this is actually the case. And woohoo! So after all this loop, it's like, OK, I've gone through the data. I think this is right based on this validation. And here we are. Here is the answer presented to you. And this is actually what had happened during that time. But here are some other things that the agent can do. So don't feel bad about answering questions. It's actually available 24/7 for conversation. You can ask it any question anytime. And the really nice thing, too, is that it can also it handles follow-ups. So as you can see, you can get really long threads where instead of whenever you ask a question and then it loses context, it preserves all of that. So it's really nice if you want to going up and you're oh, this is slightly off or something. And then also, when you ask a question, it also exposes its chain of thought, so you can interrupt it if it's going in the wrong direction or something, or you phrased your question incorrectly and you just need to provide a little more details. And also, the agent kind of acts kind of like an assistant in how it will ask for clarification if it's unsure. So in this case, I didn't really say what I had a question about. I was OK, what's the DAU of? And I just left it there. The agent is assuming, OK, maybe I mean overall product DAU. So it tries its best to pick reasonable defaults if you don't respond, but otherwise you can just follow up and say so. And for commonly repeatable processes, we have these things called agent workflows, which are basically shareable custom instructions, so you don't have to keep repeating yourself for routine tasks. And we find that this was really useful, especially for team processes where you're just commonly doing something really repetitive. Every morning, you're prepping this oh, what's the latest and greatest of this past week's data or something. That's a common one, feature product analysis. Another common one is doing data validations on tables. So you produce a local table, you want to compare it against a prod table. Easiest to have, just launch it in agent workflow using your internal agent, and you can go do something else. So I've said a lot about, OK, what it actually looks like, how you use it, but how does the magic actually happen? So this is the overall big picture diagram of how things happen behind the scenes. So on the left, we have our entry points, which was shown in a previous slide. In the middle, right, it's the most important part. We have our agent. And then on the top and the bottom are the pieces of context that are actually available to the agent. And so the top part are the pre-processed context pieces. So retrieval is really fast. And so that includes both data information, but also company context. And at the bottom, we actually have our sync calls. And so the agent can live make API requests to data services it cares about. And of course, the model, the most important part on the right. And of course, agents without context can give wildly wrong answers. So here's an example. When we asked it about the ChatGPT wow, I thought it was 5 million, but actually we have about 800 million launched, and this was announced dev day. So just minor running detail here. Here are the different layers of context that our internal data agent uses. Let's start at the bottom with table usage. So as you might have guessed, we can't possibly fit 70K tables with their schemas and query history into a context window. That's impossible, and that's extremely slow, even if we were able to do that. So we actually do a bunch of pre-processing ahead of time so that retrieval is fast. And part of this information includes table schema, so it knows how to write the queries, and then also the columns and the types and any annotations that are particularly useful, for example, privacy annotations or things like that. But you might think, OK, is this all we need? And actually, we also enrich the table information instead of just having schemas, but with query history and table lineage and information based on that, so that it has a more holistic view. So we basically, it's not just how the table is structured, but it's how people actually use these tables, right? That's a really important part of writing correct queries, or especially with joins. The other important piece, too, is how we actually make it available to the agent at runtime. So this offline piece, we actually do this by putting all of it into an embedding, and then the agent basically does reg retrieval at runtime. So it only basically selects the subset of table information that is relevant for the question. So in this way, all of the data is potentially available to the agent, but the agent only gets what it really needs to get. And you can search by it. Table name or specific keywords based on the question. So that is layer 1. Layer 2 is human annotations. And this is really helpful for starting out and for key tables. But another common problem with human annotations in particular is that descriptions can get easily outdated, and often they can become a burden to maintain. This leads to bad results. I think outdated results are worse than no results at all, and it's kind of tedious to just keep manually updating them. So we solve this by actually auto-generating as much as possible. So, and from this, with these auto-generations, we actually include information from the code base so that not only do you know kind of what the table is about, you know exactly how it was derived from the log, like the API log from the request specifically, and then how it traverses our data pipelines to get to that table. So that's kind of combined with level 3, the Codex enrichment. So this is, I think I was mentioned, but these are kind of things that you might get from code, using code as the source of truth. And this is just so helpful for the agent because there's those little nuances that I talked about earlier. This is how you get those answers. So things actually, what is the table actually doing? Maybe it says it's doing this because it was from 5 years ago, but actually from the code, this is what it's doing today. So this is how, for example, use cases, you know that the table is filtered down for this set of logs. And so how this actually works in practice is we do this for a subset of tables, since it is a longer pipeline, but this can be done ad hoc as needed for a particular table in the UI. So we have these Codex tasks that are effectively launched in parallel, and then they crawl the code base to get these basically important information, and then this is surfaced to both end users and also just to the agent. So the agent is just constantly aware of all these little details that are so useful. And so instead of knowing that a table is only for ChatGPT analytics, you know that it includes first-party ChatGPT data, and it's enriched with safety sources, and excludes things when these signals are missing. So you have that exact information, and this otherwise, you have a human doing this, and it's outdated in the next day or so. This is how we keep things really detailed but up to date. Layer 4 is institutional knowledge. And this is really important for providing the extra context on the why for a question instead of just the what. So this is really useful when the agent is kind of generating analyses or hypotheses, right? We saw a spike. Why did it happen, right? Using Slack, we know that maybe there was an incident. Using docs, we know that, okay, this is like the launch calendar, right? Or this is like the name of, like when someone uses like an internal code name, it knows because it has that product context. It knows exactly like this internal code name refers to this ChatGPT product, and this is the tag that it's used in this table for filtering. And so basically, this is powered by an internal OpenAI service that ingests this data, and similarly, it also ingests it in a way that it's all available, but it picks it up at runtime, and we also there's some caching and permissions checking as well, just to make sure that you only retrieve what you're supposed to retrieve. And level 5 is actually memory, and this is really useful for things like corrections and learnings. Here's an example. So with the memory, for example, it's able to query something in a minute, but without the memory, it takes that much longer. So the memory is kind of, in this case, the memory is like a shortcut. It's like, okay, like these are just the little extra tips that if you knew this, like you go right away, instead of the agent being like, oh, let me try this. Nope, didn't work. Let me try this, and so on and so forth. Another example of how memory is useful is for corrections. Like if there's a very particular nuanced way to answer a question, and maybe like for this experiment you have to filter by this experiment name, and it's like this weird string, like that is something that the agent would know. And the really lovely thing, too, about memory is that this is how the agent can continuously learn and improve. Context gets you maybe like 80, 90% of the way there, but sometimes you need those like little final corrections. And when, so for example, when you need to know that the experiment, as I talked about, this is how you do it, and it retains all of this memory. So when you ask it again, it's able to answer the same way for everyone else down the line. And so memories are actually made available and easily so that everyone can contribute to making the agent better. So in our conversation, you can save a memory, and it's like auto-suggested if it finds that the conversation, it has like some learnings. And right now, memory has 2 scopes. So this is global, which is accessible and available for all users. But we also have personal, and that's just for security reasons. If there's something like either like a little sensitive, or you just want it just for you, you care about this particular thing. And so there's 2 ways of inserting memory. Yes, the agent way, this is the suggestion that I'm referring to, or you can manually do it. And the last layer is runtime context. And so this is for, okay, offline isn't enough, and maybe offline is like outdated, right? And so the agents can actually make live calls to all of our data platform services, like our data warehouse, just to find what it might need. So we can talk to Spark or Airflow. And an example of when this might be useful is maybe you created like a new table like 2 minutes ago. That's not going to be in any offline system. It was just created, but it is useful to query, right? Maybe you're doing some testing. And so you can get the agent to directly pull any information live about this table as needed. So hopefully this image illustrates how important context is. The next important factor that I kind of want to talk about is how we ensure we don't have regressions. So let me talk about how we measure response quality. So in the words of the wise Rag Brockman, evals are surprisingly all you need. And there's a lot of truth to that in our case. Our evals consist of sets of question-answer pairs. A question is usually some more important metric. Maybe it's an exact metric that we want to get right. And then we also have a manually curated expected SQL statement that we generate, that we know that has the right answer. So we hit the agent query generation endpoint to get what the agent would have produced. And then we do something, and then we get results from that. So we get the SQL, and then we run the results, and then we get the results from the expected SQL, and then we throw that all in. So we have the generated SQL results, the expected SQL results, and we throw that into the evals grader. And a lot of times, like generate SQL actually is just slightly different, just because there's like multiple ways of like expressing SQL to represent the same thing effectively. Like you can date compare in a bunch of different ways, right? But this doesn't meaningfully change the answer. And so that's why we use an LLM grader to catch these little nuances. And then we finally get a score and a reason behind it. And so here are some core takeaways that are specific to our evals process. And so kind of I alluded to this a little earlier, but exact SQL text equality isn't really a good representation of whether a SQL eval should be passed or not. And so we normalize the SQL by converting things to its AST representations, so you don't get these like weird things like, oh, maybe there's a comment here, or like, oh, like I'm representing this slightly differently. Also, when comparing result sets, we give the LM grader like a little bit of wiggle room, so that because in some cases, right, like for even the results like slightly different, it's not meaningful. Like something is a float, but it doesn't change the answer versus like an int. And LMs are actually really good at reasoning about these failures. So instead of being like super prescriptive, like maybe if you had a script to do this, the model again is really good at like kind of evaluating these like little differences. And the other part of our evals that was really helpful for us in our harness was being able to see the chain of thought of the agent when we were debugging eval failures. And so we actually exposed this when debugging our evals. This is really useful because sometimes you don't know why it failed, and so having them coupled together is really useful to dig into exact specifics. So in one failing case, we saw that it preferred a curated table over raw table because it thought that the question was more on the dashboard side. With great data access comes great responsibility. We make sure that the agent doesn't provide any extra authorization. It actually does pass-through authentication. So this means that whatever you have access to when you're manually writing a SQL query versus the agents running or creating a SQL query on your behalf, you're not getting granted any extra permissions. So this means that if you don't have access to a table, the agent will tell you, like in the screenshot, or it will try to use a table that you might already have that maybe is like a slightly more aggregated, or maybe it drops some sensitive columns or something. Data security is also something we take very seriously at OpenAI. Users should only be accessing data that they have a legitimate business purpose to. We don't want to overexpose, even in the metadata case. So for example, because we add query histories, we make sure to sanitize all of them ahead of time. So we redact any PAI literals to avoid them kind of seeping into the agent where this metadata is broadly accessible. And sometimes users actually do need to see sensitive results. And so we do allow users to see this by pointing them to a web page where they can see their full results. So sometimes if they're in a spot where maybe the platform is a little sensitive, we redact, and they can just open the UI and they can see these results. Or if you're sharing information, this is also very common. You create an agent thread, you share it with your colleague because you want to show your analysis. We apply a permissions check there as well because we want to make sure that your colleague should have this data access as well. And just like a human, the agent can also make mistakes. So that's why we stream the agent's chain of thought as it's answering a question. So kind of how you all saw a little earlier, you can see exactly what the agent is doing, so you can kind of audit it each step of the way. And you can also see kind of how it arrived at that assumption. This is really useful for if you're trying to learn more from what the agent did, or if you're okay, does this make sense? Is this reasonable? And as you saw earlier, also another part of it is the queries, right? These are the frames of reference that usually, looking at a number, it's hard to tell whether it's right or not. Or maybe you have a rough idea, but you're not sure. And you can look at the query, and you can exactly see, oh, yes, this table makes sense. And of course, for any queries that run, you can always view the data results. And these are these links are shareable, and they're also permissions controlled. So now we deployed it at we deployed this at OpenAI, and we've gotten a lot of user feedback. I think it's been really positively received, and people are now default relying on the agent to actually write queries instead of just hand-rolling it themselves. But let me kind of talk about the lessons we learned along this journey. So the first kind of thing that we realized after doing some iteration was that when you give them the model too much information, it actually gets a lot more confused. So in our case, this actually manifested because we had a bunch of different tools that kind of had overlapping functionalities. Like one tool was for like a user case, one tool was like slightly different, but like very similar for like a service principal case. And so to a human, maybe this is kind of obvious, right? But actually to a model, it was like, oh, like I'm not sure, like how do I pick? And so when we restricted basically the tool calls that the model was able to do, this was actually really helpful for the model being exactly like, oh, I just know exactly like what tools to go to. And also the other thing that with, I guess, tool calls that I kind of want to share is we realized that the agent wasn't good at consistently calling tool calls. Like we would put in our like system prompt like, oh, like use this tool, and then use this tool, but maybe sometimes it would just skip this step or something, or maybe it would deemed it irrelevant. But we thought after looking at the answer, it's like actually no, that was super important. We put everything. We basically consolidated tool calls, and then. So there's this one big tool call that it calls, and then it deterministically calls these 3 sub-tool calls. So that's a way you can kind of control that. And the other thing, too, that we realized was to not be overly prescriptive in the instructions. There's a lot of different types of questions that people can ask. And when we started off, we were like very, very like specific. Do A, B, C, D, E, F, so on and so forth. But actually, we found that like having maybe a general kind of framework or guideline for how to answer the question and then letting it to the agent to decide exactly like little nuances was a lot better, right? Sometimes, like for example, someone is just asking for resources, or someone is asking about like, oh, like how do they validate this? These are all like data questions, but there's obviously different paths to getting there, right? And so being more general actually yielded in better answers, especially with like all the different kinds of questions that we see. And so finally, I kind of want to talk about, how can you do something similar if you're, looking to set your own internal data agent up at your company. Firstly, what was really useful for us was just leveraging an infrastructure and just not hand-rolling everything ourselves. So a lot of model platforms like OpenAI, we have a lot of this tooling available. You can use whatever is, best at your company. But for us, right, like they had, okay, talking to the model, we could use there's an embeddings API for creating those. There's an evals platform. And that, leveraging this existing infrastructure allowed us to spend time on the things that we actually cared about, like how we create the context. Like that's the most important piece. The other stuff is a little more mechanical. And so this really worked really well for us because we could, again, spend that time meaningfully to deliver faster and iterate faster with users. Another thing that we leveraged very heavily was Codex. So with the small team we had, it was actually really useful to have Codex to iterate really quickly with users, especially for web development. It's able to kind of see a browser. That was really useful. And this sped up development a ton as we kind of iterated on the features. So that was a lot of me talking. Thanks for not falling asleep. If there's anything you take away from this talk, I hope these 3 things stick with you. So remember that A, it's really important to have context beyond just table metadata. Remember that code context is really useful. Keeping context up to date is really important. And also company context, like that product context, really, really useful. Secondly, incorporating memory is really important for just agent like iterating. You want this agent to contain kind of all the knowledge from all of the, from all of the different like product folks or data analysts. Like we want to capture all of that centrally. And then finally, evals are really important to making sure that your model just doesn't regress whenever you're making like new code changes to the actual generations. Okay, that wraps up my presentation. Thank you so much for listening.